Hello friends, I have already started the embedded system lectures. I hope you have seen my first lecture on the embedded system. So today I will continue with the introduction to embedded system. So what are the advantages and how we can use the embedded system? This I have discussed on the last lecture. Okay, so what are the main components are there in embedded system that I am writing now? Okay, first is the sensor. Second, ADC, analog to digital converter. Third, processor. Fourth, DSP, digital to analog converter. Fifth, actuator. What is the function of this thing? This I will discuss in this lecture today, but not now, later. So before going to the each and every part of these components, first I like to know that what is the main processor. Okay, so processor is the main part of the embedded system. Okay, processor is the main part of the embedded system. So if we divide the processor, it can be divided into three parts. Okay, microprocessor, microcontroller, and DSP, digital signal processing, digital signal processing. Okay, so what are the difference between microprocessor and microcontroller? That I'll tell now, and DSP, that is a little bit different from the microprocessor and the microcontroller. So DSP, digital signal processor, this is a one kind of the processor, but it normally do the normal kind of mathematics kind of the function. Okay, but with the microprocessor and microcontroller, these are related to languages, assembly languages. Okay, they have to follow some instruction and execute some code. Okay, based on the applications. But the DSP, suppose you are sending a one sinusoidal wave and one sinusoidal signal, and one is the cosine signal. So into the DSP. Okay, and you are doing some multiplication, or if you want to do addition of both the signals. Okay, so for that digital signal processing is mainly required. Okay, to do some mathematics function. Okay, multiplication, addition, subtraction, and suppose one system which contains first addition, after that multiplication. Okay, so for this purpose mainly DSP is required. And again, so DSP also is required. There are the varieties of applications in for DSP: image processing, speech processing. You want to analyze the image, or to analyze the speech, you want to multiply the both different kind of the speech and the radio radar signal processing. That the application of DSPs are there. Okay, so now come to the difference between the microprocessor and the microcontroller. Normally, microprocessor and microcontroller both are based on the coding and the assembly languages. Okay, so now what is the main difference between the microprocessor and microcontroller? So normally the microcontroller you can also write as a MSC, and the microprocessor is also there. Right. So main thing is that here, first to think about, this is only the single chip. Okay, but it is mainly based on the CPU, central processing unit. Okay, it's not only contain only single chip, and it has a cost effective, but it is based on silicon chip. Okay, so integrated chips are there inside the microprocessor, but it is only one kind of the single chip, semiconductor based single chip, right? In every, if you think about in each and every electronic components which are doing only normally the specific task inside those devices, microcontrollers are there, but the microprocessor that are doing some kinds of the tasks. Okay, so normally inside the computer you will have the microprocessor, central processing unit. So microprocessor that only contains the central processing unit which are doing some logical operation or arithmetic operation. Okay, and some specific general purpose use. Okay, a microcontroller, it has to perform some specific task. Okay, specific task, certain task. Okay, Short form, I am writing in the short form. For that you will easily understand, you can easily remember what are the main difference between the microcontroller and the microprocessor, right? It can perform the specific task and it can perform the certain task, right? So for microcontroller, if you think about the washing machine or microwave, okay, or digital clock, so you will have the timer, okay, or counter. Okay, some devices which needs the timer and counter. So for these devices, my embedded systems is required. Okay, so here timer and counter already available. Okay, you can design any kind of the timer circuit using the microcontroller, but in this case not available. You need some other component for designing the timer and controller. Okay, so these are some single chip CPU based chip, cost effective. It is based on the silicon, so that's why it is not cost effective. It can perform the specific task and it can perform the certain task. It has the timer counter available and does not have. Okay, and now come to the some other points. Okay, so here RAM, ROM. Okay, these are internal memories are already available. You can also connect the external memory. Okay, here does not have any memory, Okay, right? So this is some other point, three simple point I am writing. One is the low processing power. So in order to operate the microcontroller, it needs the low processing power, and here it is high. Here also the size is small. Okay, here the size is large. Okay, suppose you computer will have the microprocessor. The size for design the microprocessor based system, you need the large circuit. Okay, here it is large, size is small. The low cost and low consumption power. Okay, here both the high cost and the high consumption power. Okay, so these are the some other points. The memories are already inbuilt inside the microcontroller. In microprocessor there are no memories. You need to connect the external memory, and low processing power. To operate the microcontroller, you need the low power, and here high power is required, and size is also large for case of the microprocessor, and high consumption power and high cost for case of the microcontroller. For microprocessor, for case of the microcontroller, all are low. Okay, size is also small and low cost and low power consumption is there, right? So I think you will have the much clear about the microprocessor and microcontroller. But normally you can use the some, if you want to in different kind of application, you can use both the circuit. But if you want to do some specific task, you need the microcontroller, right? So now come to the microcontroller. I will discuss about the microcontroller here in the coming lecture also. So microcontroller, you can also write as a MC. Okay, this is the short form of the microcontroller, right? So normally, it is a one kind of the microcomputer. Micro means it is a one kind of the microcomputer based on single chip. It is one kind of the microcontroller based on single chip. Normally in microcontroller it will have the only one semiconductor based single chip. Okay, in case of the microcontroller also it will have the only one single chip, right? And normally, and apart from this, it has the internal memory. This is the some switches. Okay, and you can connect external memory. Okay, so inside the embedded system, we will have the microcontroller. Okay, so what is the main function of the microcontroller? Microcontroller will collect the data from the sensor. Okay, and it will perform some experiment, it will perform some task. After that, based on the, it will have some code. Okay, so microcontroller executes those code. Okay, and based on the code, it will give some instruction to the actuator to perform experiment. Okay, so suppose you have the washing machine, right, or you have the AC. Okay, so it will detect some temperature, and then microcontroller will know that if temperature is this one, so automatically it can control the fan, or it can start the motor. Okay, like this way. So microcontroller, it will collect the input from the sensor, and it will execute some code. After that, accordingly, it will give the output to the actuator or motor. Okay, sensor means, or it will have the keypad and any kind of the virtual, any kind of the physical thing. Normally, we want to deal with the real world and the digital world using the microcontroller. Okay, and microcontroller, that means I am writing here. Okay, sensor, take data from sensor. Okay, in the form of keyboard and actuator. That will transfer into the actuator after execution of code. Okay, after execution of code, it will transfer some data to the actuator in the form of so these are the keyboard. Keyboard is there. So from the keyboard, it will collect some data. Okay, and transfer to the microcontroller. It will execute some code. After that, the modified form of the data will transfer into the actuator in the form of the motor. Okay. So, what I told, and this, the code. So, the code is normally based on the assembly C code. Okay. In advanced version, you can use the Python code also. Okay. And Python code also. Okay. You can also use the Python code. Okay. So normally you will have the one software, you will have the microcontroller board, and you will have the software. Okay, and so in software you can write some code, and the software will compile and execute those code, and this code will be transferred into the hardware. Okay, by using the USB cable, the code will be loaded into the hardware. Okay, after that, whatever platform you want, whatever applications you want to get, you can execute the application, this specific task inside the hardware of the microcontroller. Okay, so for that you need some specific application based assembly C code for microcontroller. And now why we can use microcontroller normally in different applications. Okay, medical application and medical application, the military applications, in our daily life, each and every systems are there, you can use the microcontroller. So normally, and also I told that in our daily life, in each and every system you can connect to the internet, that will become a IoT. So when you are integrating internet connectivity with the embedded system, or you are integrating internet with the microcontroller, it will become an IoT device, right? So in our daily life, AC, fan, digital clock, washing machine, your smartphone, router, internet, everywhere you can connect the embedded system, right? In military application, and there are lots of applications in the military application and medical applications also. Okay, now here I told that suppose sensor is there at the components. I told that sensor, EDC, processor, DSP, actuator. Okay. So here Here normally I will give the example of the washing machine, okay, by using this one. Okay, what are the principle of this block diagram of the embedded system? Okay, inside the processor you will have the microcontroller, suppose. Okay, so I am telling about the washing machine. Okay, so what it will do, supposing you can see you will have the some keypad. Okay, power option. Okay, power option will be there, and start option and the power option. So you can see the two different kind of the buttons are there, keypads are there. One is the start keypad, one is the power keypad. Okay, when you press the start and the microprocessor, the washing machine will be turned on. After that, you can see lots of keypads are there. You can change your program and how long the washing machine will clean the cloth, and in which way it will clean the cloth. It will be quick wash or it will be the normal wash, and how long it will be clean, or it will only clean the cloth, or it will only rinse the cloth, or it will only wash the cloth. So based on that, you can program something. Okay. After that, you can press the power option, and that time the microprocessor will start to clean. Okay, so when you press this keypad, okay, so you are pressing the keypad, you are giving the signal from your side. Okay, you are giving the signal what kind of the platform you need, applications you need. Based on that, you are giving some input to the keypad. Okay, this keypad, so here some sensor will be connected. So the in power and start, this will be acted as a sensor only. Okay, so the data, whatever press option you are giving, so this data transfer to the digital. Okay, the keypad, your keypad normally acted as an analog of sensor. Okay, and sensor normally that will transfer the signal from physical signal to the electrical signal. That will be in the form of the analog only. Okay, so when you're going about the processor, the microprocessor, micron, these are only the digital processor. Okay, digital system. So for that, you would whatever information you are sending from inside in the form of the analog, that will be transferred into the digital. Okay, so the data, see they're pressing something. Okay, press button in the form of the analog, that will transfer into the ADC. Okay, after that, the ADC data, the ADC means analog to digital converter. This data will be transferred into the digital. Okay, so whatever input data will go into the microprocessor, after that it will understand that. So it will understand, okay, I need to clean the, after that microprocessor will do, I need to rinse the cloth, wash the cloth, and clean the cloth, and spin the cloth. Okay, so based on this one, some program should be there. Okay, so this rinse will be continue for this time, and after that this will be continue for this time. Whatever instruction, input instruction will get from the sensor, based on that it will execute some specific code. Okay, so for such kind of the input, it will have one code. For different kind of the inputs, it will have the other code. The microprocessor will execute those code based on your washing machine. Okay, how long it will be continue. So after that, you can see the data in the and after that washing, what the actuator will do, it will execute some code. After that, it will give output to the actuator. Okay, so suppose you need to there will have motor, so for rotating the cloth, and the passing the water, and the spinning the cloth. Okay, these are mechanical functions are there. Okay, microcontroller will execute those program. Okay, based on that, the mechanical function will be activated, right? And accordingly, you will have the one timer display. Accordingly, the microcontroller will give the instruction to the timer also, so to display how long it will be continue, right? So that means, so when it comes to the mechanical part, okay, again the analog portion is required. After execution, those data will be some, you will get some output, right? After execution of the code, so those data will be transferred into the DSP. Okay, again here you will get the analog data. Okay, this is the modify output or executed output or modify output. Okay, this should transfer to the DSP when it's come to the actuator. Again, analog data is required, actually mechanical. So again, it will deal with the real one. Okay, there will be some motor. You need to rotate the cloth. Okay, spin the cloth. For that, again, analog part is required, which is deal with the real one, right? So that's why. Again, you need the actuator, and then for timer, to display the time, you need the timer, okay, which is available inside the microcontroller, right? So this is about the each and every, what are the function of the each and every part. If you will have the confusion, I will again repeat this thing on the next class. So please like, share and subscribe my channel, and I will discuss some interesting point in the coming lectures. Thank you.